Hey guys, this is Fred from Pretty Fly Games, and today we're going to continue with our top-down car controller built in Unity. I've been getting several questions about how we handle surfaces in Total Arcade Racing. So in this episode we're going to go through how you can add different types of surfaces, grass, sand, oil slicks, etc. to your top-down racing game or any other top-down game. So, to add surface support in a game, we're going to add a new game object to make sure that our project view doesn't get too cluttered. So let's put this in position 0, so let's reset it, and let's call it surfaces. And then let's create a new child object to that one, and this one we are going to call outer collider. Outer surface, and we're going to add a component to it, and it's going to be a polygon collider. Alright, so now we have our polygon collider here, and we're going to switch it so it becomes a trigger. Now what we will do is that we will move our polygon here, and this is going to be a trigger that determines what type of surface the player is driving over. So what we will have is the default is going to be the road surface, and this sand part is going to be, well, sand, and then we can add some oil slicks as well on the road. So what we need to do now is we need to outline this polygon so it covers our whole area that we want to define as sand surface. So right now I'm just dragging out these parts, and sadly there isn't any easy way to do it. You can probably, if you want, include this information in your tile information, but I've found that it's actually easier to do it this way because maybe we want to have some dynamic like oil spills and other things, and potentially we want different types of surfaces to overlap. So let's just keep on working with this until we have pretty good coverage of our level. It doesn't have to be like exact, so yeah, let me just keep going, and yeah, I will be done shortly. Alright, now I'm done with that. So when the car is driving on our road, we are going to check what type of surface is under the car. And as it exits from the road and enters our polygon collider here, this is actually going to trigger, and we are going to notice that, yeah, we are driving on some other type of surface. But we want to make sure that we're only checking for surfaces. So we're going to add a new layer, and we're going to call it surface. And then let's assign surface to this layer. So now we are actually ready to start doing some coding, and we want to be able to define a type of layer for this. So you can use tags for this and specify a certain tag, etc. But I prefer to actually do a script for it. So let's create a new folder here, and we will call it surface. And let's create a new C# script, and we'll also call it surface. And let's open that in Visual Studio. Okay, so here is our surface script, and it's actually going to just contain some basic information. We want to be able to have different types of surfaces, so let's make a enum for this. So we're going to have a public enum surface types. And they can be road, sand, grass, or oil. Now you can add anything like ice or whatever you want to this, but for now we are going to have these basic types. So this makes it very easy to extend this with additional information. And then of course we want to have what type is this specific object. Now we have just defined the enum, so we will do a public surface type and have it called surface type. And maybe we can tidy up our code a little bit more, and we can just have something called surface. So we get a nice header. So let's save that and go back into Unity. Now let's select our outer surface here and drag and drop our surface script and select the surface type sand. So that gives this sand or the surface type of sand. Okay, so let's save that. Then we need another script that will sit on top inside the car, and it will detect what type of materials is the car driving on. And we want to sort of separate this from our game logic, so let's call it car surface. So car surface handler, and let's open that in Visual Studio. This script will detect what type of surface we're driving on, and we are going to use a physics overlapped collider for this. So the physics overlapped collider is going to use a collider that we provided with, and in this case we're actually going to use the shape of our car. So we need to be able to get our collider that we're using for our car. So let's add that as another component, collider 2D car collider. And of course we need to get that, so we'll void awake, and let's get that on awake. So we will use get component in children and collider 2D. So this assumes that there is a collider 2D attached to our car, which there is. Okay, so let's use that in the first parameter. Now the second parameter is a contact filter 2D. So this determines actually makes it possible to provide some more information to our overlap collider, what type of information that we are interested in. Normally when you're doing like a raycast or anything like that, you actually supply like the layers information that you're interested in, etc. on this call, but in this specific case you have to use contact filter 2D. So let's create a new contact filter 2D, and then we are going to specify some things in it. First of all, we want to be able to actually detect only surfaces. So right now, if we would run this, it would detect anything, including the car and other cars and all the other information that we have in the scene, which we don't want. So we want to specify a layer that we are going to use for detecting it. And we have already said that we're going to use our surface layer. So let's provide a layer, public layer mask surface layer, so that we can easily change it from the editor. Okay, so the contact filter is what defines what type of layers and etc. we are going to use. So let's set our layer mask to be equal to surface layer. And then we need to configure a few more things, like we want to use the layer mask, otherwise it's not actually going to use that. And the default is not to use layer mask, so we need to make sure that it uses that. And the second part is that this by default doesn't react to triggers, and our surface is a trigger, so we want to specify that we're going to use triggers. Okay, so now we can use that, and then we have all our result that is going to be provided from this function call. So let's create some variables for that, and it's going to be a collider array. So let's make a collider array, and let's just make it in size 10, and then we can supply that as well. Now this function will return an integer which specifies, okay, how many things were actually hit or detected. So let's use that int number of hits, and it's going to be supplied to whatever we had. All right, so then we are going to get a list of all our surfaces, and it could be empty, meaning that we didn't actually find any surface. So what are we going to do? We are going to loop through whatever we found. So let's do a for loop from 0 to the number of hits. So that will effectively loop through all of our surfaces. And then we want to get the information about our surface. So let's do a surface and call it surface. And then from our surface collider hit here, from that index, we are going to get the component surface. So that gets us the information here. And as we have defined that we are only going to look in our layer mask called surfaces, we know that it actually will have a component called surface. If it didn't, we're going to get an error saying that it couldn't find it, so it's going to be a null exception. But in this case, we actually know that, okay, we found something. And in this case, what we will do as well is that we will check the order of the different surfaces. So this gets a little bit complicated, but think of it like this. So maybe we want to have a surface like here, and we call it sand. And and we'll just type here sand. And then we have another layer under it that will be road. And then we have an oil slick, maybe, right? So we have oil. When we are doing this hit check up here, overlap collider, it's actually going to sample all of these three. And we have no way of knowing which is actually on top of it. And what we want is, we want the top layer to be the one that we are getting, the top information. So if we have multiple colliders overlapping, we want to use the one that is has like the highest value. That way we can put an oil slick anywhere on the road or anywhere in the sand, and it will get the oil first, and then it will get whatever is under it. So that makes it easier to build our level. But we need to be able to store some information to handle that. So we are going to do add a new variable, and it's going to be a float last surface z value. So the z value starts from the lowest value in 2D, the furthest away from the camera, below the floor is going to be some negative value. So we're going to say that the lowest possible value is minus 10,000. And then we are going to check, okay, is our current surface that we found here, does it have a larger z value than our last value? And as we're starting at minus 1000, the first one is most likely going to have that. Okay, if that happens, then we are going to store our last surface z value and going to say, yeah, this is the one. This is the current one with the highest value. But we also need to sort of sample our surface here. So let's create a variable so that we know what surface we are actually handling. So let's do that. Surface, and we're going to create surface type, driving on surface, and then it's going to default to road. So when we are reaching this point, we can assign our variable here. So driving on surface is going to be equal to our surface. And of course we need the type. So then we are updating this driving on surface. And this is going to loop through all of our surfaces. But we need to also make sure that we are catching the case where there is nothing returned. So remember that I said that actually if nothing is returned, it means that we are driving on the road, because then we don't have to define create a polygon for the whole road section. So we're just going to create polygon colliders for anything that is not road. So So if our number of hits is 0, then we're going to say that, okay, actually our surface that we're driving on right now is road. And then let's just debug this. So we can add a debug log, driving on surface, and then close brackets. So if we would run this now, it would check this every frame. And right now we're running sort of 60 frames per second at least. Maybe with modern computers we're even running it faster. And we can do some tiny optimization, like we don't have to check this all the time. So what we're going to do is we're going to add another variable here, and we're going to call it under hit check. So we're going to call it last sampled surface position, and that's the position where we checked last. And to get sure that it runs the first time, we're going to add like a silly value, vector 1, and multiply it by 1,000. That will create, or 10,000. That will create a position being 10,000 units away. So this will then start this check. So what we will do is we will check if our transform has moved a certain distance before we check this again. And so here we go. Let's do that. If our transport position minus last surface position dot square magnitude is larger than 0.75, then it means that we are going to run this, but we can just make it an opposite here and say that, okay, if it's not, then you know what, we're going to return. We're not going to run this part of the code. But we need to store our position here. So let's do that. Last sample position is going to be transform.position. So now we have a slightly more optimized solution here, because we only need to check this at certain interval if the car has moved a certain distance. And you can adapt this value to the need of your game. And remember, it's square magnitude, so it's a fairly small value. So you can try this out. It's not the same as magnitude, it's square magnitude. But you can try it out and see what value is good for you. I think 0.75 is going to provide a very high accuracy for this game. So let's leave it at that. So let's save this and go back into Unity. So now we need to use that. So let's go into our prefabs and let's open our car. And let's add our car surface handler. And this needed to be configured, so the surface layer should be surface. Okay, so if we save this now and take it for a spin, we should be able to see what surface we're on. So now we can see in our console here, it says driving on road. Perfect. And now it says driving on sand. So the detector is actually working, and yeah, that's awesome. Now we can detect different surfaces and add them easily into our game. But right now the game doesn't really care what surface you're driving on. Everything is the same. The handling is the same. The graphics, well, is the same. So we need to change this to make it a little bit more interesting. So the first part is that we are going to make sure that our car controller is actually picking this up, so we can, well, do different things with it. So let's go into our car top-down car controller here, and then in our top-down car controller we will start using our new surface handler. So let's add that in components, car surface handler, and let's get that component on awake, and then we can actually start using it. So the first part is, well, to make it more maybe visually interesting. So when we are driving on pavement or the road, we can use our regular like wheel particles, but if we're driving off-road, then maybe we want to have more particles, and we also want them to change color, for instance. So in this case, the wheel particle handler is just aware of what is going on in the top-down car controller. And of course we could add a reference to our car surface handler here and pick up and see what type of surface we're on. But for now, instead, we're going to try to organize things a little bit more. So our top-down car controller here, we're going to scroll down and we're going to add a function to it, so we can actually get our surfaces directly from it, because it becomes a little bit tedious to have too many scripts lying around. And I'm just going to see where we have jumping, so we don't add it in the middle of the jumping part. So we have get our velocity, so let's add that after this part. So we are going to do a surface type get surfaces, and we are going to return car surface handler, and we're going to get the current surface. But there is no function for this. So we need to add that in our car surface handler. So let's go to our car surface handler and let's create a new function for that. It's going to be a public, and then it's going to be a surface type, and then let's return our surface. All right, so when we are calling this function, it's gonna get this copy of our driving on surfaces or surface, which is great because we are not running this every frame. Some frames it wouldn't have been updated properly maybe, but this is going to be the last value that we had when this was running. So now we have that, and our top-down car controller has this get surface, and it's a public, which means that other scripts can access it. So what we wanted to do was that we wanted to create some more interesting particles when we're driving off-road, and we want to be able to change the color of our particles. So to do that, we are actually going to need to access our main module of the particle system. So let's add that main module, particle system module, and at the start we are going to, or in the wake here, we are going to get this as same as we did for the emission component. So let's get that. Okay, so then we are going to check our code here. So we have our reduced particle over time, and then we have our is tire screeching, which is causing the particle system to emit more particles. We want to use something similar, but not exactly the same. So we will run this before our is tire screeching, so that you can also screech your tires off-road. And we are going to use a switch statement. So we are going to do a switch statement on the top-down car controller, and we're going to get the surface. A switch statement is an easy way to make multiple sort of if statements. So instead of having like if car surface is equal to road, if car surface is equal to sand, etc., we can use this. So our first part is going to be a case here, which means that the surface type is road. So in that case, we are going to take our particle system main module, set the start color to be, well, something sort of grayish, which it already is, but we need to make sure that if we have been driving on sand surfaces, we need to reset it again. And then we use a break. So that is the encapsulation of this code. Then we will do the same thing for our sand surface, but with an addition to that. So we're going to set our emission rate to another value. It's going to use the top-down car controller get velocity and magnitude. So it means that as we are driving faster or slower, we will have more or less emission. And then we are going to use brake to stop that. And then let's do the same thing for grass. But in that case, let's use a sort of greenish color to it. And if we have oil, then we are just gonna change the color to be quite dark, close to black. So if we would run this code now, it means that the particle system will get our surface from the top-down car controller and execute this code. But it doesn't break our is screeching. Well, it affects it, but it doesn't break it. So we will still have the ability to break and get this nice extra particles, etc. Okay, so let's save that and try it in Unity. So let's take it for a spin. So if we drive here, it's all the same as it was. And if we are exiting the road, then we can see that, great, we have new particles that are coming up and are darker because we're driving on sand. Now it doesn't work over here because we don't have a polygon collider here. So that's something we can fix later on. But I mean, it's all good. We are getting some visual information that we are driving on sand, but the car handling is still the same, and we would like the car handling to change. So maybe when you're driving on sand, you shouldn't be able to, well, it should slow down the car, and maybe you should slide a little bit more. And especially if you're driving on oil, then we want to influence how much traction you have in your tires. So that's as well something we can easily change now that we have control over our surfaces. So let's open our top-down car controller again, and let's have a look at our code a little bit here. And we want to be able to make sure that we are actually slowing down whenever we are reaching an area which is maybe sand, as I said before. So we have our code already here that is setting the drag for our car. So the drag is how much, for how much it's going to get slowed down every sort of frame. And right now it is only slowed down if we let go of our acceleration button. If we are pressing our acceleration button, it puts the drag to 0. And we want the surfaces to be able to be a little bit more dynamic, so we are going to change that part, and we are actually going to lerp it instead as well. Then we are going to do the same thing as we did with the particle system. We're going to make a switch statement, and we are going to check what type of surface we're driving on. So if we are driving on a car surface which is sand, then we are going to increase our drag a little bit. And what we will do, we will increase it over time. So we're going to lerp from whatever value it has until 9, and we're going to do this at the rate of fixed delta time times 3. So it's actually similar to how fast we apply it when we let go of our brakes or our acceleration here. Then let's do the same thing for our grass type, and we are going to make it a little bit stronger, so you drive even slower on grass. And in case that we are driving on oil, we are going to take the drag down to 0, and we are actually going to stop the ability to brake and sort of reverse or brake even more when you're driving on oil. So if the car acceleration input is something less than 0, then it's going to be clamped to 0. So you will not be able to apply brake input while you're driving on oil here. And that's something that you may want to have, or that you can decide yourself if you want. But the drag is going to be 0, which means that it's going to be very sort of slippery. And then we want to sort of do the same thing for our the ability for us to drift. And we are going to have our drift become adapted by the surface that we're driving on. So right now we have this drift factor here, and instead we are going to call something that we call current drift factor. This is just so that we don't override our drift factor. We're going to leave that as it is. So current drift factor is going to get a value from drift factor. And if we are driving on a surface that is going to affect our drift, then we will change this value. So in that case, we are driving on sand. We are going to say that our drift factor is going to be 5% higher. So we multiply it with 1.05. So if we have set up a car that has a specific drift, we want to maintain it that ratio, so that's why we are multiplying it by 5%. So otherwise we would overwrite the value, and we will actually overwrite the value if you are driving on oil, because it doesn't matter what type of car you have and what initial drift factor it has. We want it to slide a lot. So let's have our current drift factor at 1. And instead of multiplying here with our drift factor, let's multiply with our current drift factor. Okay, so let's save that and try that in Unity. Alright, so here's our car. So let's drive and let's go a bit off-road. Now we can see that it's actually slowing down a lot more. So when we're off-road, it actually increases the drag like it should. And if we are just doing sort of touching it a little bit, the other surface, then we can quickly recover again. But if we get stuck out here, it's going to take a longer time to get back. So that's pretty cool. So let's add our oil and see how that can work. So actually I'm going to take this surface here and I'm going to duplicate it, and let's call it oil surface, and I'm going to get rid of our polygon collider here, and I'm going to re-add it later on. And we're going to have a sprite here, which is going to be our oil stain. So let's search for oil. I've actually added it because it was in the sprite sheet. So in the sprite sheet there is an oil, so I cut that out and now we can use it. So if you're going to do that, then you would go into sprites and look at our sprite sheet here and objects and press sprite editor, and then you can assign that as a separate sort of object here. Okay, so our oil surface here, we're going to move it and we're going to make it pretty large. So let's make it maybe 3, something like that. And then let's re-add our polygon collider so it actually detects how it looks. And then don't forget, it needs to be a trigger. And yeah, then you can edit it if you want it to fit better, but that works for us. And then, as we said before, we added our sorting part here. So if we want to make sure that this is detected as the top layer, then we need to increase our Z value a little bit. So 0.1 is enough. So that means that it's actually sitting a little bit on top of our sand here. So yeah, if we drive now, then it will detect our oil. And actually it needs to be changed as well. I forgot that. Surface type is going to be oil, of course. All right, so now we can try it. Yay, look at me slide. So that's nice. So now we have an oil stain that we can move, and we can put it on top of the sand if we want to, or in any other place. So what is missing now is that we need to add another polygon for our inner part here. So let's duplicate our outer surface and call it inner surface. And to reset all of our current points, let's go into points, path, elements, and just change the size here to 4. That will destroy our shape, but it's easy to move it around. So let's just add this very quickly. Oops. There's an extra, so let's hold on. Oh. Doesn't really matter if we have more polygons than or more edges. Right, there we go. That's good enough for me. And it's gonna be sand. So now we have completed our level with the different surfaces. And of course you can add more effects to this. Like if you're driving outside here, maybe you want to have a different sound effect playing. yeah, so the player becomes aware that, okay, I'm driving really off-road here. Same with grass, maybe you want to have some special thing happening. But this is how you add support for different surface layers in a top-down racing game like this. I'd like to give a shout out to our Patreon supporters. It helps us with every single contribution that we can get. So please consider supporting us on Patreon. The link is in the description. This concludes this episode, and I hope that you enjoyed it. If you did, please give it a thumbs up and hit that subscribe button and the bell to get a notification when the next video is out. Here's an example from our game, Total Arcade Racing, which uses this component for its physics, inputs and other powers. You can find the game on Steam, PlayStation, Xbox and Nintendo Switch. Please take it for a spin if you want.